Welcome, everybody. In this video, I just want to go through some equivalent forms of rational expressions. It's sort of just a reminder video to make sure you completely simplify your problems. So our first two examples actually simplify really nicely, but you may not recognize it right away. So for instance, here you have 2 plus x and then x minus 2. Now remember that addition is commutative, meaning that the order can be rearranged. So if I rearrange the numerator and flip these around, I get x plus 2 over x plus 2. So if I take a moment and pause, hopefully you'll recognize that we actually have the same expression on top and bottom. So when you have the same expression on top and bottom, so these are basically sort of stuck together like this, they would cancel out because, again, they're the same. Now, when things cancel like this, you do always have a factor left over, and that is 1. It would be the same idea if you had something like 7 divided by 7, right? 7 over 7, that cancels, but it doesn't just become 0, it becomes 1, right? So it's the same idea here. You do want to make sure you don't cancel things individually, remember. So I can't cancel the 2's and then the x's. That's not how that works. You want to be really careful here. And when you have addition and subtraction, we cancel them as factors or groups. Now, the second example, it's something similar, but I have subtraction. Now, subtraction is not commutative. So if I'm going to rearrange, I have to be really careful here that I don't mess up my signs. If you want to, you could change the subtraction here to adding a negative if you find that helpful. But in either case, that 2 is positive in the numerator and the x is the negative 1. So if you're going to rearrange, you do have to be extra careful because you can't just flip things any way you want. You really need to watch that subtraction sign. So the negative is on the x and the 2 is on, the 2 is positive. Now, if you're looking here, you're saying, hey, these are really close, but again, they're not quite the same. I can't just cancel the x's and the 2's. But notice that I could maybe factor out a negative from the numerator. And when I factor out a negative 1, or just a negative, I have positive x left, and then 2 divided by negative 1 would be negative 2. Now, once I remove that negative, I do in fact see that these now become identical, right? Positive x minus 2 in both cases. So this does cancel, and I'm left with negative 1 as my final answer here. Now, you do have to be really careful. Again, watch that subtraction because it's not commutative. So if you're going to rearrange things, you need to make sure you don't mess up your signs, right? That x needed to stay negative and that 2 needed to stay positive. The other thing too, when we factor out that negative here, notice that these two pieces are exactly the same. Not everything is going to cancel perfectly like this, right? So in this case, they were both x minus 2, so I could cancel. You know, if I factor out a negative and this was x plus 2 and x minus 2, then again, that wouldn't help me. So it really depends on the problem and making sure that when you cancel factors, they are identical. The last thing I want to note here, there we go. The last thing I want to note here is just this example, and I want to show you how we can write our fractions or our rational expressions in different ways with negatives. So for instance, having a negative out front is the same answer as if you put the negative in the numerator or in the denominator. So just with numbers, for instance, like negative 1/2 written like this is the same as negative 1/2 written like this or like this. So if I have one negative, I can put it really anywhere I want to, and it's going to give me the same answer, although it may look a little bit different. So this is one way to write this expression, is just to have that negative out front. Now, if you wanted to stick that negative with the numerator, though, you would have to be careful here because we don't just have one term in the numerator, right? We have two terms. Here I just had one term. I just stuck it with the 1. But if you're going to take that negative, if it's hanging out outside and you're going to put it with the numerator, you would have to distribute that negative throughout. So this now becomes negative 5x plus 1 all over x plus 9. So although these are the same exact answer, again, they're going to look a little bit differently because if you put the negative with the numerator, it's going to have to distribute through to the entire expression. And then the same thing would be true if I put the negative with the denominator. Like this, again, I'd have to distribute that negative through. So I had 5x minus 1, and then negative x minus 9 on the bottom. Now, I will say that this is probably the least common way to do it. We don't usually leave the negative in the bottom, but you could here. So again, this is another way to write it. All three of these are technically the same answer, but they look a little bit different depending on where that negative is. So again, you just want to be really careful as you move things back and forth between the different forms. You can also go the other way. So I could start with this form and go back to one of, the other forms as well. When you're taking a negative out though, do remember that you do need parentheses, so that that negative is going to the whole expression, right? So you do want to be careful as you're moving that negative around. If you're factoring back out, it needs to come out of both pieces in the numerator like it did here to reverse back to this form. So you just want to be careful with your final answers. And again, note that there are sometimes multiple ways to write that final answer. So if you're getting it correct, but maybe your answer looks a little bit different than mine, it could just be that you have the negative in a different position. So just be careful with those negatives.